Venus has mountains that appear to wear metallic frost. That should be impossible. The hottest planet in the solar system should erase anything that resembles snow. Every instinct built from life on Earth says the same thing. Heat destroys frost. Heat leaves bare rock. Yet when a spacecraft mapped Venus with radar, the highest mountains shone back with extraordinary brightness. The change was so sharp that it traced the mountain ranges almost like a snowline. The strangest part was not that the bright peaks existed. It was where they began. Across different regions of the planet, the brightness appeared only after the landscape climbed above a certain elevation. Below that invisible boundary, the surface looked ordinary. Above it, the mountains suddenly reflected radar like polished metal. Something changed with height. And whatever it was, it transformed one of the most hostile worlds we know into something that looked strangely familiar. The spacecraft never saw these mountains with ordinary cameras. Venus hides beneath an unbroken blanket of thick clouds. Visible light cannot reveal the surface. Instead, the mission sent radio waves through the atmosphere and measured how strongly they bounced back. Those echoes became a map. When scientists compared the radar reflections with the planet's topography, the pattern refused to disappear. Every time the highest ridges emerged, the reflections became dramatically stronger. The anomaly was real. At first, the mountains seemed like the obvious explanation. Perhaps their rocks were simply different. Perhaps ancient geology had exposed unusually reflective minerals. That idea survived only until the maps grew larger. The same sharp transition appeared again and again across widely separated highlands. The boundary followed altitude far more faithfully than individual mountain ranges. It behaved less like a unique rock formation and more like an environmental threshold. The mountains were not merely different. Something was happening to them. That realization quietly overturned the simplest picture of Venus. Instead of being a motionless furnace where every surface behaved the same way, the planet hinted at an active process that cared about elevation. The next clue seemed almost disappointing. The higher you climb on Venus, the temperature falls. Not to comfortable conditions, not even close. The highest peaks remain hotter than a kitchen oven, but they are roughly 80 degrees Celsius cooler than the surrounding plains. On Earth, cooler mountains often mean snow. On Venus, that explanation collapses immediately. Nothing there is cold enough for water ice. Yet the reflective boundary still follows the cooler elevations. The resemblance to a snowline survives even after the possibility of snow disappears. That raises a different question. If water is not condensing, then what is? The answer begins with the atmosphere itself. Near the surface, Venus possesses an atmosphere so dense that it behaves very differently from the thin air surrounding Earth. Under crushing pressure and intense heat, it becomes an extraordinarily effective chemical environment. Tiny amounts of material can move through it in ways that seem completely unfamiliar to everyday experience. The atmosphere is no longer just something rocks sit inside. It becomes part of the landscape's chemistry. Researchers began asking whether trace amounts of heavy elements could slowly escape the scorching lowlands as vapor. If those vapors reached the cooler mountain heights, they might settle back onto exposed rock, creating an extremely thin coating that changes how radar reflects from the surface. Suddenly, the impossible peaks no longer looked impossible. They looked like the visible fingerprints of an invisible chemical cycle. Not frozen water, condensed minerals. The image remains surprisingly familiar, even though the process is entirely alien. Earth's mountains gather snow because water changes state as temperatures fall. Venus may gather metallic compounds or other unusual minerals because different chemicals respond to its own extreme environment. The pattern is recognizable. The substance may be completely different. Laboratory experiments strengthened this remarkable possibility. Scientists recreated Venus-like temperatures, pressures, and atmospheric chemistry inside specialized chambers. Thermodynamic calculations showed that certain heavy compounds could behave exactly as the radar observations seemed to require. Materials containing lead or bismuth became leading candidates because they could vaporize under lower conditions and become stable again at higher elevations. The investigation, however, refused to end there. Another explanation remained equally serious. Perhaps no thin coating exists at all. Some researchers propose that the mountain rocks themselves change their electrical behavior under cooler conditions. Certain minerals could naturally produce the unusual radar reflections without requiring a deposited layer of metallic compounds. The evidence supported both possibilities better than many people expected. That created an unusual scientific situation. The observation was solid. The explanation remained open. Normally, a mystery like this would invite a direct visit. On Venus, that solution is extraordinarily difficult. The mountains responsible for the brightest reflections have never been sampled. Earlier landers survived only briefly on lower plains before the planet's crushing pressure and relentless heat overwhelmed them. None reached the rugged summits where the mystery is written into the rocks themselves. Scientists, therefore, possess extraordinary confidence about what they observe. They remain carefully uncertain about exactly why it happens. That distinction matters. Reality does not become weaker because one answer has not yet won. It becomes more interesting. Every new measurement must satisfy the same stubborn evidence. Any successful explanation has to account for the sharp altitude boundary, the dramatic increase in radar brightness, the changing temperatures with elevation, and the chemistry of one of the harshest atmospheres in the solar system. The mountains continue waiting. Their reflective surfaces have outlasted generations of competing ideas. Seen from orbit, Maxwell Montes stands as the clearest reminder of that unfinished investigation. Its highest ridges shine with the same strange signature that first challenged simple assumptions about Venus. The mountain has become more than a landform. It has become a record of a planetary process still unfolding beyond direct human reach. The greatest surprise is no longer that Venus appears to have metallic frost. It is that the familiar idea of weather was too narrow all along. The same physical principle that allows vapor to condense on Earth can emerge under utterly different conditions when chemistry, pressure, and temperature are rearranged. The result does not resemble gentle snowfall or winter ice. It becomes something far stranger, a blazing world where mountain summits quietly accumulate the signatures of an alien atmosphere. Nothing about Venus became colder. Only our understanding of weather became larger.